Welcome to the Electronic Security Networking Technician Webinar Training, Section 3. The ESNT, or Electronic Security Networking Technician program, is a training, testing, and certification program for physical security technicians and company employees, people involved in the installation of alarm systems, CCTV systems, and access control systems. This program is administered by the ETA, the Electronic Technicians Association, and the training consists of these webinars that you're viewing now and your attendance at a one-day hands-on networking lab and that's also where we provide the written certification test. You can check our website, SlaytonSolutionsLTD.com, for certification class and testing dates that are going to be held in your regional area. My name's Dave Engebritsen. I'm going to be your trainer, and I have 33 years experience in the security business. I'm Network Plus certified, I'm ESNT and fiber optic certified, and my company, Slayton Solutions, provides webinars and live training classes in networking and fiber optics for the physical security industry. This section of the training is Section 3, and we're going to talk about network cabling. And it's an important section because many times the problems that we might run into in trying to connect cameras, NVRs, etc. onto a customer's network are going to come down to the simple things, the cable and connectors. That's what we're going to talk about today, as well as some cabling options and some information about fiber optics. The standards for cabling are provided to us by the EIA-TIA, the Electronics Industry Association, Telecommunications Industry Association. They established the standards for what are called structured cabling systems, and these original standards were set up in the late 80s, and they've been amended some since then. But basically, they talk about in the standards the type of cable, the type of connectors, the maximum distances of cables, which is an issue for us, and the performance parameters of the cabling and connectors and how they're supposed to work in the network. Now, most of you are familiar with UTP, unshielded twisted pair, Cat5 cable. And you're probably aware that the conductors inside a Cat5, a standard Cat5 cable, are solid copper, typically 24 gauge. And if you strip the outer jacket from a Cat5 cable and look at the pairs, there's usually 4 pairs, and you're going to see the pairs are twisted at a different rate. Some are twisted tighter, and some are twisted with fewer twists per inch. Why are they twisted that way? They're twisted that way so that it doesn't eliminate, but it greatly reduces what would be crosstalk between the cable, between the pairs underneath the jacket. And the twisting also helps us reduce, but not eliminate, the effects of electromagnetic interference and radio frequency interference, or EMI and RFI, getting into the cable. Understand our Cat5e cable that we're typically used is not shielded, and now the Europeans, they're all about shielded cable, but we're not here on this side of the pond. So our typical Cat5 cable is not a shielded cable. Now, the cable performance is measured in bandwidth. How much data can a cable pass? And that measurement is in megahertz. It's important to know that if a cable's poorly installed, if it's improperly handled during installation, if it's improperly connected or poorly connected, or it's a bad installation, or you got problems in the patch panel, anywhere where you can have these difficulties or where these things can occur, this can make it so things don't work right. So we really need to make sure that our cable and our connectors are properly done and properly handled. Now, the EIA-TIA set up the standards for the cabling. We're going to talk about what those are here in just a minute. The cabling types that are used are typically, nowadays, you don't see too much Cat3 anymore, and Cat5 is no longer recognized. The most common cable that we use to connect IP cameras and intercoms and door locks is going to be Cat5e cable. It's a 100 megahertz cable. It's common stuff. You've probably handled it many times yourself and installed it. It's It's typically used for 100 megabit Ethernet or 10/100 Ethernet, and it works just fine. And you can buy it in different configurations. You see illustrated here an outdoor cable that has, can be run outdoors. You can get it in outdoor rated cable. You can get it but primarily it's run inside of buildings. Now there's higher grades of cable, Cat 6 and Cat 7 and Cat 6A. These are used for 1 and 10 gigabit Ethernet networks primarily. I want to make this point clear. For the devices for our industry, the devices that are common today, even the megapixel cameras, the Cat 5 cable is perfectly acceptable. You don't have to use the Cat 6 or Cat 7. A megapixel camera, maybe it's putting out 12 megabits per second. You know, that 12 megabits can easily go through a 100 megahertz cable, can easily go through a 100 megabit Ethernet connection. So as long as the cable's done right and as long as the connectors are done right, you're going to be okay with Cat 5e. Now, if the customer already has Cat 6, Cat 6a, or Cat 7, you can use that cable if it's available. That's okay, but you don't need it. That's the important point I'm trying to make. Now, for Ethernet transmissions over UTP, unshielded twisted pair, if it's a 10-100 transmission, it uses 2 pairs to transmit and receive the data, the orange and the white orange, the green and the white green. So the transmission situation looks like this. We have transmit and receive. And remember from our previous sections, every device on a network, you know, let's say you hang a network camera on the wall, it's got one jack on the back, and it's going to be plugged into, it's going to be connected with cabling to one thing, typically the network switch. So this is how it's going to look, transmit and receive between, say, a camera on the left side and a network switch on the right side. Now, if you're doing gigabit Ethernet, you use all 4 pairs of the typical 4-pair cable. And here you see the scheme in which it transmits the gigabit back and forth in a full duplex configuration or full duplex communication. This is important for you to remember. When you're doing your jacks, when you're doing your cabling connections, make sure you terminate all 4 pairs and do it the right way. Because that cable you put in now today that you're going to run 10-100 Ethernet on, someday you might want to run gigabit Ethernet over that cable. If you do, you're going to have to make, the cable's going to have to be right. So we got to make sure all 4 pairs are terminated properly. Now, the EIA-TIA sets standards for the distances of the cable, and the primary distance standard that they look at is Cat 5e cable for 100 megabit Ethernet. The maximum distance per the standards is 100 meters or 328 feet. And what they're talking about there is the horizontal cable, and by that we mean we have a jack on the wall, and that behind that jack there's a cable. And remember, or I should mention, every jack is going to be home run back to the telecommunication closet on its own cable. So if there's 2 jacks on a plate, there's 2 cables that come there, 2 individual cables, 1 for each jack. They go back to the telecommunication closet. We can have 90 meters of that in the wall and then 10 meters of aggregate jumper cables at each end. These are the EIA-TIA standards. And here you see an illustration of a typical structured cabling system. The one thing that's not real clear here, and I'll point out where you see the desktop in the upper right-hand side, that's going to be the plate on the wall. That's going to be the plate that has the female RJ45 sockets on it. Then we've got the horizontal cabling. That can be the 90 meters. Then we have the telecommunication closets. In the telecommunication closets, which are also sometimes called intermediate cross connects, this is where our network switches are, our UPSs are, and then if there is more than one telecommunication closet, and often there is in a big building or a big location or a high-rise building, those telecommunication closets will be connected up to each other via cabling called the backbone. Now the backbone most often is fiber optics, but it can be copper if the distances are good or are short enough to do it with. Now I do want to point out one thing here, and I want to make this very clear. The maximum distance in the EIA-TIA standards for Cat 5e cable for 100 megabit Ethernet is indeed 100 meters or 328 feet. I have connected IP cameras up to 500 feet of Cat 5e cable on a roll to see if it would work, and indeed it did work. I'm not telling you to not follow the standards. What I am telling you is that if we are a structured cabling contractor and we are selling a structured cabling system to our customer, we're going to adhere directly and right on the standards, because that's what we're selling, a standardized structured cabling system. If, on the other hand, we are a security contractor and we are selling them a CCTV system, an IP CCTV system, what's our standard of performance? That they can see the picture on their computer screen, or that the video is being recorded. So what I'm going to tell you is, and let me make this clear, you should try to stick with the standards. But if you're using high quality cable and you're connecting it properly and you need to go an extra 20 or 30 feet, I certainly wouldn't be concerned about doing that, as long as you understand what you're doing and that you haven't sold it to the customer that we are installing this to the EIA-TIA standards, because that would be wrong, okay? And understand there are other ways to extend that distance. There's a couple of ways we can do it. If we need to go more than 100 meters or 328 feet from the network switch out to our physical security device, our card reader, our camera, our video encoder, our NVR. Now, when you're installing UTP cable, it's very important that it be handled gently. Understand that UTP has a Cat5e has a maximum pull rating of 25 pounds. That's not much. So we need to be very careful as in the pulling process, because if we pull it with more than 25 pounds of pulling power, we will start to untwist the twists underneath the jacket, and this is going to cause deficient cable performance. So we want to make sure we don't excessively bend or flex the cable during the installation. Remember that the conductors in a typical roll of Cat5e cable are solid copper. What happens to solid copper if you flex it repeatedly? It's going to break, right? It's going to break internally, just like if you take a coat hanger and you sit there flexing it. You know, you flex it enough and it snaps in half, right? Well, same issue with the Cat5e cable, the solid conductor stuff. So make sure you don't excessively bend or flex it. You want to make sure that if you're using tie wraps, that you're not using a tie wrap gun that's going to squeeze. When we put a tie wrap around a cable, whether it's UTP or especially fiber optic cable, the cable should be loose under the tie wrap, in the sense that the cable can move. It should not be, the tie wrap shouldn't be torqued down so much that it is squeezing the jacket of the cable. We want to make sure that our terminations are done properly, and we're going to talk about those in a minute. And one of the things that you need to remember is that if we tightly bundle our cables together, we can develop a bad thing called alien crosstalk. In alien crosstalk, let's say I've got 10 Cat5e cables and they're tightly bundled together. The green pair in cable 3 starts talking to the green pair in cable 5, which starts talking to the green pair in cable 7. That's called alien crosstalk, and that's a problem. When you go into a modern enterprise structured cabling system and you look at how they cable it, if it was done right or the way it's typically done, you'll see that they don't put the cables into tight bundles. They have cabling trays, or like a runner, and they lay the cable individually in the tray, and that's what carries it across the factory floor, or that's what carries a bunch of cables up the wall. They've got them spread out. They don't bundle them together. Bundling them together can cause problems. So remember that when you're doing your cable pulling. Now, this is where a lot of our problems happen. It's in the jumper cables. It's in the jumper cables going into the patch panel, or it's in the terminations at the end of the cable. The first problem we often have is that the RJ45 sockets that we put on, we need to make sure they're put on correctly and understand that they aren't, even though they work very well, what often happens with repeated insertions and connections in and out, the little plastic spring clip loses its spring. It's happened to me many times in training classes. And when it does lose its spring, it doesn't click in securely to the device you're plugging it into, the network switch or the camera or the NVR, whatever it is. If you are plugging something in and you don't get that firm click, well, you got a problem, and the problem is that connector needs to be replaced. because if it doesn't click in firmly, you know, it can fall out or it can wiggle itself free. You don't want that. So make sure you get a firm click when you stick your cable in. The second thing I want to point out here is that if you're using jumper cables to get from the patch panel into the network switch or wherever you might use a jumper cable, purchase jumper cables pre-made from the store. Don't make your own jumper cable. Why? Because the Cat5e jumper cables, the cables that are made for jumpers have stranded conductors in them. Stranded conductors are built so that the cable can move around a little bit and be flexed a little bit, and the connection doesn't break. If we make our own jumpers out of a roll of Cat5e cable, well, repeated flexing, repeated movement of the cable could snap the copper conductor internally. So buy jumper cables. This also brings up the point, and this is an important thing to remember. You want to use the jumper cables that have the level of performance of the cabling system. If I have a Cat5e horizontal link, as it's called, in the wall, and I plug in a Cat3 jumper cable, what level of performance am I going to get? I'm going to get Cat3 performance. So the jumper cables should match the bandwidth. The bandwidth of the jumper cable should match the bandwidth of the cable in the wall or exceed it, so that you get the highest level of performance. Now, often when we want to program an NVR or a DVR or a camera, we want to connect directly from our laptop computer into that device itself. And the way that's done is through the use of a crossover cable or crossover connection. And what this does is it crosses the white-orange to the white-green, and the orange crosses to the green, so that what is transmitted on one end is received on the other. You use these if you're going directly from your computer into a device and you're not going through a network switch or hub. Now, you can buy crossover cables pre-made. I buy them. I have a couple of them. They're red, so I know they're crossover cables. You can make a crossover cable if you want to, or they make a little adapter called a super looper. That's a $5 adapter, goes on one end or the other of a standard jumper cable, making it a crossover cable. And you only need one of them, and they're $5. So you might as well buy a super looper and throw it in your bag. Then you always have a crossover connection if you need it. Now, the way we've got our typical Cat5 cables got 4 pairs. And those 4 pairs have to be connected up a specific way. And the way that they're connected 9 times out of 10, or I should say 97% of the time, is what's called the 568B termination. And you see the termination listed here. Now, one of the real common mistakes that's made by technicians is a complete reversal of the pairs. You start at the wrong end. The thing to do is to look at the jack. Here we've got our jack we're going to install. Take a jumper cable that you know is good. It is a properly made cable. Hold it up with the spring clip in the same, aligned the same way. Let's say the spring clip is away from you. Then hold up your jack that you're going to connect. And before you crimp it or before you cut the cable, before you finalize it, compare the pairs in the one you made to the one you know that is good, making sure that the spring clip is aligned the same way. This will verify to you that you put the pairs on right, because again, it's very common that the pairs are improperly done. This also brings up the point that when you are doing UTP cabling with RJ45 sockets, male or female, everything should be wired exactly the same. You shouldn't be swapping pairs around. Every single jack should be wired 568B, and every pair should be on every jack, male or female, the exact same way. Very important thing to remember. Okay, so here you see our typical RJ45 UTP connector. The technical name for it is the 8P8C, but everybody calls it an RJ45 jack. And here are the pin positions. It's pretty straightforward stuff. And the one that I like is called the EZ RJ45. I like that termination kit because you push the wires all the way through the jack, so that then when you crimp and cut with the tool the pliers-like tool that crimps it and cuts it, you know that your conductors are going all the way through. I don't like the jacks where you have to trim to length and then try to get them to fit in. It's not a good idea. Get that EZ RJ45. That's the best one that I've seen to do terminations on a UTP cable. Now we're going to spend a few minutes talking about fiber optics, because fiber optics is a very useful technology for the physical security business. There's basically two kinds of fiber that are out there today that you can use. And one of the beautiful things about fiber optics is that it's all standardized. So when you go to your customer's location and you're walking around and looking at it, you go in a telecom closet and you see a bunch of orange jumper cables, you know that those jumper cables are, if they're orange, they are going to be multi-mode fiber. If they're yellow, they're going to be single-mode fiber. Now, let's talk about the difference between multi-mode and single-mode fiber. Multi-mode fiber gets used for relatively short distances, typically less than 2 miles, but you actually can go out as far as 5 miles in some applications of multi-mode. Multi-mode fiber uses LED light sources usually, so the transmitters and receivers are less expensive than the single-mode fiber, which requires a laser. Now, the core of the multi-mode fiber is going to be 62.5 or 50 microns in diameter. And a micron is a millionth of a meter, so we're talking real small stuff here. A human hair is probably 80 or 90 microns across. So we're talking about something that's the core of the fiber, where the light signal travels, is thinner than a human hair. Now, in our multi-mode fiber, we can use less expensive connectors. We can connectorize this stuff ourselves in the field. We can put on the connectors and splices ourselves. Multi-mode fiber is relatively forgiving of, let's call them, installation realities. Nothing's perfect in our world. We'd like to make our fiber connectors perfect, but they're not. They're close. So let's say that you're putting a set of connectors on, and let's say that your connector, based on the manufacturer, how you handled it, let's say your connector's off by 5 microns. Well, if your multi-mode, if it's a 62.5 micron core multi-mode fiber, and you're off by 5 microns, that's about 12%. So you're going to have about a 12% signal loss. That's not a problem for fiber optics, not for multi-mode. Now, if you look on the right-hand side and look at this core size of the single mode at 9 microns, it's much smaller core size. That core size is so small that if we're off by 5 microns, we're off over 50%. So we got a real problem there. So multi-mode's easier to work with than single mode in terms of the connectors and the splices. What are the uses for multi-mode fiber? They run it between telecom closets. It's good. It's great for CCTV, whether you want to do analog or IP CCTV on it, and fiber optics to the desktop. The reason that multi-mode gets used over single mode is the fact that it uses the LED light sources. That makes it less expensive, makes the overall installation less expensive. Now, our single mode fiber on the right-hand side goes much further distance. We can go out to 60 miles on a single mode fiber before we have to regenerate the signal. Single mode fiber is always going to use a laser light source. Lasers are more powerful lights. They're more expensive lights. Also, lasers turn on and off faster than an LED does. So do you see that when we're transmitting data, and by the way, we can transmit analog or digital or Ethernet over either kind of fiber. But when we're transmitting, whatever the kind of data it is, if our light can turn on and off faster, do you see that it can transmit more? So single mode, because it uses lasers, gives us higher bandwidth. In fact, where the bandwidth of a multi-mode fiber is about 48 times that of a typical Cat5e cable, the bandwidth of a single mode fiber they have yet to find the end of it. There is lots of bandwidth in a single mode fiber. But the connectorization and splicing process must be very, very precise. And you need expensive equipment to do the connectorization properly. So, Single mode is going to get used by the cable companies. It's going to be used by the telephone companies. How does the cable company bring the triple play to your house, where you're getting 200 channels of TV and you're getting your phone service and you're getting 3 megabit up and down internet connectivity? How do they do that? They install what's called an HFC, or a hybrid fiber coax network. They bring single mode fibers to your neighborhood. They bring them to a box. That box has power. AC power comes to it, and inside that box are electronics that take the blinking laser light that is coming through the single mode fiber and convert it into its electrical component and then push it out on the coax to your house. So that's how they do it. So single mode fiber, huge bandwidth and great distance, and it's going to be used by the phone companies, it's going to be used by the cable companies, and by anybody who wants the maximum bandwidth they can get from point A to point B. Now, for us, I understand in the physical security business, I've been in this business a long time, most dealers are not pulling fiber optic cable. It's just not what we do. However, understand that there are millions, literally millions of unused, or as they're called, dark fibers that are already installed. When a cable is installed, when a fiber cable is installed between two buildings, you know, let's say it was installed in 1997 and they cabled these two buildings that are 1,000 feet apart. They did it with fiber because they wanted to put Ethernet on it, and you can't run Ethernet on copper 1,000 feet. We learned that earlier. So they had to put in fiber. So they're going to put a cable, they're going to direct bury a cable between these two buildings. Typical Ethernet on fiber is going to be two fibers, one to transmit and one to receive. So that cable they bury in the ground between the two buildings has to have at least two fibers in it. But you know what? The cable that they buried probably has 6, 12, or 24 fibers in it. Why did they pull the extra fibers? Well, first of all, it is made of glass. There is the potential of breakage when you install it. Even though I'm going to show you, we're going to talk about how to install fiber so that you don't break it. But if I need two fibers to work between these two buildings and I pull a 6-count fiber, you know, I can break one and I still got 5 left, so I'm still good to go, right? That's one reason that they pulled the extra fibers. The second reason is that the fiber, the business part of the fiber, the glass, the core and the cladding that carries the blinking light signal, it's made out of glass. Glass is made out of sand. Sand is dirt. The core and cladding, the fiber optic links that are within the cable are less expensive than the wrappers, the protective elements in an outdoor cable. So the cost differential between a 2-count fiber and a 6-count fiber is virtually nothing. So they're going to put them in extra fiber. And the fiber industry has been stressing for years, always pull extra fiber. You never, if you're going to do that cable run from point A to point B, or you're going to run up the riser of a building, always pull extra fibers. You don't know when you'll want them, but you'll be real glad they're there because they're the biggest pipe. And remember, with fiber optics, it's a blinking light signal. Therefore, it is completely immune to EMI and RFI interference. So when you're looking at a job, and it's a big job, one of the first things you should ask the owner or the network people or the physical plant manager is, are there any dark fibers or unlit fibers in your cabling system that we can use to connect up our security devices? And if they'll let you use them, you know what? You just became a horizontal Superman. You just went 1,000 feet and you got there like that. Boom, you're there. And there's plenty of manufacturers, whether you want to transmit Ethernet or whether you want to transmit analog cameras, you want anything you want to transmit over fiber, transmitters and receivers are available. You want to do RS-485, you want to do up the coax, pan-tilt zoom, whatever you want to do, there's somebody builds the boxes that do it. So the fiber's there, the fiber's available. Always ask for it on those big jobs, and you have got to ask for it, because if you don't, your competition will, and then they're going to come in with a much lower price for the installation, and that's going to, you know, and we got to sell jobs. Nothing happens until something gets sold. Now, in fiber optics, as far as it relates to Ethernet, here you see a chart of the distances that are available, maximum distances per the IEEE. And you notice that when we're doing when we're doing multi-mode fiber, we're doing fast Ethernet, we can go 2 kilometers. You know, a kilometer, basically 3,000 feet. You can go 6,000 feet on multi-mode fiber, way farther than you can go with copper cable. And you see, as you work your way down the slide, that when we get into gigabit Ethernet, we can go, you know, if it's multi-mode or single-mode fiber, you know, we can go gigabit Ethernet on single-mode fiber, you can go 70 kilometers before you have to regenerate the signal. Now, the common fiber optic connectors in our industry, the most common one is the one you see on the bottom. It's called the ST, Sam Tom. It is a round connector, and it's got a little metal post on it that fits into a slot on the female side of the connector or the adapter, and then you turn it with a clockwise turn. It's spring-loaded, and it holds the white part, which is called the ferrule. That's got the fiber in it. The polished fiber end is in it. It's got the ferrule in it there, and that holds the fiber into the connector, into the adapter. Another type of connector that's very common is the one you see above it, the square one. It's called the SC, the Sam Charlie. That is a square connector that is a push and pull. You don't twist it, you push it and pull it. It has the exact same size ferrule as the ST. So really, these two connectors are the same thing with a different body style. But the one that's most common for the physical security industry is the ST. And if you're looking at fiber optics, you need to look at A, what kind of connectors do they have, and B, what kind of, you know, when you're looking at the optoelectronics, which are the boxes that are going to do the signal transmission and receiving, you need to look at them to see what kind of connectors they come with. And be aware that whatever changes you may need to make, if you've got a device that's an SC device and you need to terminate to an ST device, that's not a problem at all. There's a number of fiber optic distributors that make specially made jumper cables that have different connectors on each end. They make adapters that you can hook as ST directly into an SC. All this stuff is readily available. So it's not a problem to go from one style of connector to another. Now, there are a couple other types of connectors that have come out recently. They're what we call small form factor, the LC and the MTRJ. These haven't really taken off the way that the industry may have wanted them to. Most all connectors, 99% of the connectors in the field today, let me put it this way. Of the connectors in the field today, whether it's in the physical security devices or networking devices, of the connectors that are in the field today, 90% of them are this ST connector. Of the remaining 10%, 90% of those are the SC connector, the square one. Okay? In networking, the SC connector is very common. In physical security, the ST connector is the most common one. And you might occasionally run into these, but not very often. Now, one of the interesting technologies that's coming out are these SFP, or small form factor pluggable transceivers. These are devices that can be plugged into circuit boards that provide different copper, multimode, or single mode connector configurations, and you can change them around. So it makes it quite attractive for manufacturers so that they can simplify their process. If a customer says, I want this to be a multi-mode transmitter, hey, no problem, we'll plug these modules in. Oh, we want this to be a single mode transmitter or receiver. Hey, no problem, we'll plug that in for you. So that's one of the innovations that's happening in the fiber optic business. Now, what are the safety rules? And you need to remember the safety rules for fiber optics because it's very important. When you are preparing a fiber end to be terminated, you have to strip the fiber, and you use a special stripping tool. This is important. You must have the proper tools to work with fiber optics. So you're going to use a stripping tool. In the process of stripping off the outer jacket and the inner jacket, there's always the possibility you're going to break the fiber, and you end up with these little inch-long or half-inch-long pieces of fiber. You know, I've had them stuck in my hands. I've had them stuck in my elbows. They don't really hurt that much. You just pull them out. But if you get one in your eye or you swallow one, that's bad news. So you always wear safety glasses when you're working with fiber. You make sure that all your broken fiber shards should be properly disposed of. They make special cans, plastic cans, to put the little pieces in. What some people do is take a piece of duct tape, rip off an 8-inch chunk, make it into a circle with the sticky sides out, put that on the table, and if you break fibers, you pick them up and stick them on the duct tape, and then when you're done, ball up the duct tape and throw it in the trash. You don't want to leave those broken pieces of fiber laying around. Now, another safety issue you've got to consider is that one of the things that makes fiber optics a little hard to grasp from a, to think about is that the light frequencies that are used in fiber optics, 850 nanometers, 1300 nanometers, and 1550 nanometers, are outside the spectrum that the human eye can see. So in a functioning fiber optic link, there's light going through it, but you can't see that light. Now, if it's an LED, we can stare at LEDs all day long. That's not a problem. But if it's a laser, the lasers used in fiber optics can be, and often are, eye-dangerous lasers, not eye-safe lasers. So therefore, you want to make sure that on the transmit, if you're going to look at a connector in a microscope in particular, this is where the danger is. When you look at a connector with a microscope, that if the laser light's coming through, the microscope's going to amplify it. If it's a 100 power scope, it's going to amplify the light energy 100 times. This, you're not going to go blind, trust me, because I've done it myself, and you'll know that you shouldn't be looking at it because you go, don't want to look at that again. Just make sure that before you inspect the connector end, make sure that there's no transmitter connected to the other end. Now, testing of fiber can be very simple. A simple flashlight held up to one end of a fiber optic link, if it goes through to the other end, a simple flashlight will go through 4,000 feet of fiber. If the light comes through the other end, that's telling you the fiber's not broken, and chances are it'll work just fine for the application of physical security devices, because our devices that we put on, even if it's a box that transmits 4 or 8 cameras, you know what? We are not really taxing the bandwidth capability of the fiber. I'm not telling you to take the short way out, but what I am telling you is that if you test it with a flashlight and the light goes through, you know the fiber's not broken, and chances are you can hook your equipment up. Now, when you're installing fiber, if you're pulling new cable, you don't want to knot or kink the fiber during installation. It should be obvious. You want to make sure that if you're going into a difficult installation, a hostile environment, a washdown area, it's going to be real hot, it's going to be real cold, something like that, that the cable you're buying is rated for that environment you're putting it in. We must meet the conduit fill maximum standards, just like with copper cable. Item 4 here is very important. You always want to pull extra fiber to have service loops at each end. If it's a long cable run between buildings, if the buildings are 1,000 feet apart, I want to have at least 30 feet of fiber coming on each end when I'm done, because this gives me the ability then to, if in the unlikely event that the fiber is dug up near the building, there's a possibility we might be able to pull that 30 feet back out and temporarily repair that fiber cable to put the customer back in service. Also, the service loops are there so that when you want to do the connectorization or the splicing, there's nothing more frustrating than when a installation company pulls fiber and they leave 3 feet hanging out of the wall, and then they tell you to put connectors on. It's real hard to put the connectors on when there's only that much cable hanging out of the wall. You want a bunch of cable hanging out of the wall so that you can bring the cable end over to the table, set up your station to put on your connectors, and do it the right way. So make sure you pull excess cable. And while we're on the subject, if you're planning a fiber optic run, make sure your length of cable you buy, and you can buy this cable in any configuration you want, indoor, outdoor, direct burial, overhead on foam poles, whatever you want. Remember though, whatever length you've got to measure very carefully the length of the cable run that you're going to do, and whatever length you're doing, if it's a long and it's going to be an expensive cable run because you're going to direct bury it or whatever, buy 20% more than you think you need, because you just don't know unless you absolutely measured it exactly what the distance is, and you don't want to come up short. it'll be the least expensive thing you ever did to buy the 20% extra. Rather than coming up 10 feet short of the building, wow, got a problem now. So make sure you buy the correct length cable. Make sure you've got the slack and service loops, slack and or service loops at each end of a long cable run. Now, in terms of the bend radius, one of the things that we look at when we're installing fiber cable is how tightly do we bend it. We do not want to bend the radius tighter than 20 times the outer diameter of the cable on the installation and 10 times the radius of the cable when it is at rest, when we're not pulling on it. So we want to make sure we do not excessively bend the cable during the pulling process, because if we do, we're going to, even if we don't break the fiber, because understand that every fiber cable, when you take the outer jacket off, this yellow stuff comes out. What's that? Well, that's the Kevlar. It's got bulletproof vest on it. Every fiber's got its own bulletproof vest. This stuff is typical fiber cable. Even the indoor stuff is 100-pound pull strength rated. What's the pull strength rating of Cat 5e cable? 25 pounds. What's the pull strength rating of fiber cable? 100 pounds. This stuff is made to be installed by real people in the real world, just like me and you. But when we take the outer jacket off, that's when, and we start to remove the protective elements, that's when we've got to be really careful with the fiber. And as you see illustrated in the lower right-hand side of the screen here, if you are buying, when you're going to terminate fiber, you should buy specific fiber optic patch panels. They have wire management hooks and systems in them, or methods by which that we can put the cable in, and we're not going to violate the bend radius of the cable as after we've terminated it and we've got it sitting there ready to go. Now, when we pull fiber cable, we want to make sure that we don't pull it by the outer jacket. Pulling it by that plastic jacket on the outside, what's going to happen is you're going to pull it, and when you release the tension, the plastic jacket's going to snap back to its original size and length, and it's going to crush and break the fiber underneath it. When you pull the fiber cable, you pull it by the Kevlar. You pull it by the strength member. It's a very simple process. Here you see where in the upper left-hand side, where we were getting ready to pull a direct burial cable through, we actually put it in a plastic conduit, but we're going to pull it 800 feet. What did we do? We removed 6 feet of the outer jacket. We removed the fibers underneath it, and then we've got the Kevlar. You see the yellow Kevlar hanging out. It's the Kevlar that you tie to the pull string, and that's what you pull, and the fiber rides along with it. Never pull by the fibers, never pull by the outer jacket, always pull by the Kevlar. And another hint for you, if you're doing this kind of thing, when we pulled this cable, the 800 feet, we had a 1,000-foot roll. We pulled it in, and when we got it to each end, the first thing I did before I terminated it is I cut off the first 10 feet and threw it away. If there's going to be any damage done to the fibers during the pulling process, it's typically going to be in that first 10 or 15 feet of cable. I'm going to take my cable that I just pulled through 800 feet of conduit, and that first 10 feet, I'm just going to cut it off and throw it away. It's garbage. And now I got fresh fiber, and that's what I'm going to terminate to. So you tie it to the Kevlar, and then you tape it up, and you're ready to pull it. Now, when we go into the commercial space, the enterprise level systems, we've got really two options. One option is to share the network. When we're putting in our cameras and our access control systems, we can share the network, or we can run a parallel system. Now, I want to, in the next few minutes, discuss the benefits of the parallel system, because I think it's real important. Now, here you see your typical enterprise network, where we've got our computers out on the horizontal wiring. We've got our telecom closet. It's connected to the main cross connect, and from there it's hooked up to the internet through a router. Typical setup. Now, if we're sharing the network, we're going to take our camera, put a static IP address in it, put in those 4 magic keys, the IP address, the subnet mask, the default gateway, and the port numbers. We're going to put that information into the camera, and we're going to hang the camera on the wall, and we're going to pull new Cat 5e UTP cable. We're going to pull it in. We're going to plug it into an open port in the customer switch. No problem. And now authorized users who have the address and the port number and the username and password, they can call the camera up and look at the pictures. That's great. But you know, the most dangerous people in the world are not the outside hackers. They're the disgruntled inside employees. And when we connect up to the shared network, now the inside employees who aren't supposed to get on our camera or our access control panel, well, it's there and they can find it. There's readily available scanning software that scans networks and finds new devices on it. And the guy might sit there saying, hey, he's sitting in his cubicle going, hey, I saw that security truck. I hear they're putting in some IP cameras. Let's just go take a look at them, right? Now, that's one issue. Another issue we've got here is that when we install cameras, we have to be concerned about bandwidth usage. And later on, we're going to discuss this bandwidth thing in great detail. But basically, your camera is going to put a load on the bandwidth because it's typically going to transmit video 24/7. So now, what happens if we put a bunch of cameras on this network and it slows down the workers on the, the people who work there? It slows down their network connection or it slows down their internet connection. Hey, they're going to start whining, right? And let's think about this for a minute. You go to this place, this customer's place, and you put 10 cameras on his network. You do it on June 1st. When you finish the job, you got it all up, it's all working, it's working great. What do? You leave. Who stays there? The IT guy stays there. And what happens when something goes wrong with his network in the next 6 months? Who's going to get blamed? You're going to get blamed, or your company's going to get blamed. Remember, blame always goes to the person who's not in the room. So there's a lot of reasons why we might not want to share the network with our video devices. What we can do is install the parallel network or the alternative network. In this case, we go to that IT person and we say, look, we'll put in our own switches. You, by the way, can buy a 16-port switch, network switch, that's got 8 PoE ports that can remotely power cameras and Wi-Fi access points and things like that. You can buy that wholesale, $220. They're not that much money. You can buy the network. You talk to the IT person. You say, we want to put in our own switches, and we want to use some of your existing backbone cabling, those fibers we talked about earlier, those dark fibers that they're not using. We're going to hook it up with fiber optic media converters, and now we've set up our own separate network. Think about the U.S. highway system. You're driving down the highway in our country, and you look over to the right. A lot of times, what do you see? You see the access road. When they built the highway, they built the access road. The highway at 8 in the morning could be all backed up with traffic, people trying to get to work. Maybe there's an accident or a guy's got a flat tire, blocking the lane. But over there on that access road, there ain't nothing going on. Guess what? We're going to go to the access road with our physical security devices. And now, what are the benefits? First benefit is they can't blame us for any of their network failures or network problems because we're not on the same network. We are physically and logically separated. We greatly increase the security of our network against inside attacks. Why? Because the only way now that somebody can attack it from the inside is if they have availability and access to the telecom closets. And certainly a physical security company, the salespeople for your company, when they're looking at selling these systems, they should be looking at the telecom closet. Is this thing secure? Does it have access control? Is there a camera inside the telecom closet to watch people coming in and out and what they're doing, right? So we protect our we protect our devices from internal attacks, and we can turn the bandwidth on our cameras all the way up. We can give the customer, the security director, the boss, whoever wants to see the video, we can give them the biggest and best pictures in terms of resolution and frame rate because we're not competing with the enterprise traffic. And this is an important point. When you're doing one of these systems, and if the selling feature is that the customer will be able to access the cameras or the NVR, DVR over the internet, you need to ask the customer when he plans to do that. Is he going to do it on off hours and the weekends, or is he going to do it all the time? Remember that the internet is used for business activities, not just to go to Amazon to order stuff. So if we are on the same network, in this example, if we're on the same network and the same internet connection with our cameras and we're feeding video through this internet connection, understand that most internet connections, in comparison to the bandwidth that's available in the local network, are very small. This backbone cabling that you see here, this might be gigabit Ethernet, 1,000 megabits per second. But this customer may have a T1 connection for his internet, which is 1.54 megabits. So do you see that the internet connection is less than 1% of the bandwidth that's available in the backbone of the network? So what does this mean? This means that if we start pushing video through this internet connection, then it's going to slow down the internet connection for the other users, for the enterprise users, if we're sharing it. If the customer says they're going to want to view the security video remotely over the internet and they want to do it all the time, then the recommendation is get a separate DSL or a separate internet connection just for the video. That way we're not hogging their internet pipe, and we don't have to hear the complaints from them that their internet has slowed down due to the video feed that's going through it. Now, the last thing we'll talk about is alternative media. There is a lot of ways now that we can transmit and receive Ethernet communications. We don't have to use Cat5e cable. There are power line adapters that I've tried them and they work. There are adapters now that work with existing coax, and what a powerful tool this is. You've got an existing coax for an analog camera that was put in 5 years ago, and it runs out there 400 feet. And the customer now says he wants 2 more cameras there. Well, do we want to pull 2 more coaxes? I don't think so. I think what we're going to do is we're going to get the transmitters and receivers or transceivers from a company like Veracity or Land Power, and we're going to use that existing coax. We're going to make it an Ethernet cable, and at the other end, at the remote end, we're going to buy a network switch. Network switch is a 6-port switch, can be $25. We're going to have to power it, yeah, and we're going to have to power those new cameras. But you know what? We don't have to pull those new coaxes to put those 2 more cameras out there. We can now run all 3 of the cameras. We make them all IP cameras. They can be megapixel, beautiful pictures, and we can run them all through that existing coax, RG58 or RG59. So there's a lot of different ways to wire this stuff with alternative media. So this is something that your salespeople and you should be thinking about when you're looking at how you're going to do a particular installation. Look for the existing cable. Look for the existing fibers. Think about how you can repurpose, as it's called, the existing cable into Ethernet and then use IP devices. Now this is the end of Section 3 of the ESNT webinar training series presented by Slayton Solutions. There are training and reference manuals available for you to study so that you're ready to pass your ESNT written test. There's the Technician's Guide to Networking Security Systems, and there's the Technician's Guide to Networking for Security Systems Enterprise Solutions. These books are approved by the ETA. They're available at our website, SlaytonSolutionsLTD.com. Also available on that website is our ESNT study guide, and you may have already purchased that, which is where you got these webinars. But on the ESNT study guide, we have got quizzes for each section to prepare you for the test. It includes PDFs of all the webinar sections, so you can print them out if you want to look at them. It has the recorded webinars. And you can secure your future in the physical security business with the ESNT training and certification program. I thank you for listening and watching this webinar, and we'll move on to Section 4.